So welcome everybody to the Art of the Probable, Test with AI, Atomic Red Team, and Threat Metrics. Thank you all for being here again. We really appreciate the time, and we know, it's late at the end of RSA, and there's lots of places you could be right now, but you chose to be here with us. I'm Adam Mashinchi, Principal Product Manager at CrowdStrike, and I'm here with...
And I'm Brian Donahue. I'm the Principal Security Specialist at Red Canary. And by the way, before we go on, if we have time for questions at the end, you're going to want to line up behind these mics, and then you can ask us questions using those microphones.
Thank you. I totally forgot to do that.
So I know. I got you, buddy.
All right. This is the obligatory disclaimer you've probably seen a number of times. Here it is again. Everybody's had the opportunity to consume it. I'm not going to read it to you. All right, let's move on. So this is the alternate title of this talk that we thought was too coy to put in the submission. Robots absolutely love to make lemonade. And hopefully this will all become very clear why we called it that here in a second. What are we talking about today? Because obviously you read the thing and maybe you just saw the title and you're like, oh, that sounds neat. This is what we're talking about. This is actually the sequel to last year's talk that we gave, maybe in this room, maybe, or maybe on the other side.
It was on the other side,
It's over there. And a few of you apparently came to last year's talk, so thanks for coming back. This is the sequel to last year's talk, and we'll talk about last year's talk in a second, so that makes sense. But what we're trying to do today is give you all some really crystalline ideas about actionable intelligence, how to find it, and then use that for your detection validation. And the big kicker here is that convergence of cybersecurity and AI that we're all talking about this week, which is using AI to synthesize and interact with threat intelligence. And that really is the crux of what we're going to be talking about today. But as a great aside, we're going to find out how to create tests on the fly with AI and create detectors on the fly with AI and hopefully show you all how to do this yourselves so you don't have to just take our word for it. You can actually give it a shot. So last year's talk, we talked about all sorts of stuff. But last year's talk, just as a summary, we itemized the current state of testing. And we were focused on TTPs, not necessarily adversaries, and we itemized kind of the difficulties around testing in your environment, that red team, blue team, purple team engagement. And we said like good, fast, cheap, and all the stuff there. And we talked about data testing versus real adversaries, and Brian went into really good detail about the disparity between those things. And then we said, there's some really great solutions for how you can do good testing using threat intelligence based off of the kinds of things we've seen. You can get familiar with tools, and you can ingest intel, and you can prioritize your testing. But at the end, and maybe it was one of the people who came back, we got a really good question, and we put the timestamp in there if you want to look it up later. But we got a great question, which is, how should one perform adversary profiling to deduce the most relevant threats? And we gave a very hand-wavy answer to that question, which is, just read a bunch of stuff, and good luck. That idea, I think we have your direct quote here.
We do.
You want to read it?
Yeah, I just said look at everything in aggregate, right? Pick 4 or 5 vendors, look at their reports, and just sort of pick out all of the commonalities from them and focus on those commonalities, because those are the things that you're most likely to face. And then I said this is overwhelming for a human, which kind of leads us to what we're going to be talking about today. So a few months ago, our director of enablement or detection enablement, he sent me this big, long prompt that he had created. And he called it the Atomic Tutor. And basically what it did is, just as a little bit of background, Atomic Red Team is a free open source testing framework. It's just a big library of tests that you can use to test your endpoints, test your detection controls and your security controls. So he created this crazy long prompt. And basically what you do is you'd give it the prompt, and then you'd feed it a YAML file from Atomic Red Team. So you'd pick a test or a technique, feed it the whole YAML file, and then it would tutor you, right? So you could ask it questions, it would answer them, it could quiz you on it, and I was like, wow, this is like a really, really interesting and useful use case for learning about Atomic Red Team. And so my first thought was we should give a talk on this tutor. But as we started to work on it, we kind of came around to a more general tool than a tool that would just teach you about testing. More useful for a wider audience, and really, really useful for sort of junior and mid-level analysts. Oh, there it is.
That was a good click for you.
Yeah, cool. So the one thing I want to preface this all with is we were like, let's create a tool that you can use AI, it'll help you create tests. But what we realized pretty quickly is the practice of prioritizing the things that you want to test, like all the work you do to go into that, you would do the same work if you're trying to figure out security controls to prioritize. So like while we're talking about testing here, like you can apply basically all of this to doing detection prioritization or security control prioritization or threat prioritization. So like the background here is like defense validation is super important. Everyone should do it. They should make sure their tools are doing what they think they're doing. But in able to do defense validation, you have to have a really good understanding of threat intelligence, and not just threat intelligence. You have to know your threat model, right? You have to know the threats that actually matter to you, because otherwise you're going to spin your wheels thinking and worrying about stuff that's never going to be a problem for your organization. And the big problem here, the one that we really wanted to solve, is that threat intelligence and threat modeling are overwhelming. So to create a really crude picture of this, right, you've got all of the intelligence that's available out there, right? But you only really care about that which is relevant to you, so your threat intelligence. And then the small subset of that is whatever things you want to do with it at that given time, which in this context are those things that you want to test. But again, it could be detectors you want to build or whatever. So hat tip to my colleague Katie Nichols, who created this slide, this very silly slide many years ago, and I use it when I talk about threat modeling. So think of it this way. The red thing is the stuff you have, right? That's you. The gray thing is them, and it's the stuff they want, and your threat model is where these two things come together. But as I was saying before, it is completely overwhelming. Figuring out your threat model is non-trivial in and of itself, and we're not really going to talk about it that much today. But trying to sort through everything that's available out there is insane, right? There's blogs, there's the news, there's like alerts and CISA advisories and stuff like that. There's annual reports, there's people tweeting all the time. You've got commercial feeds, you've got rumors, you've got super secret email groups that no one ever wants to invite me to. And it's all like way, way too much to consume. Like my theory is that there are more minutes of security content on the internet than there are minutes in the average human lifespan. So like there's no way anyone can consume all of this. And like even beyond that, like within all of that stuff, there's all these crazy variables, right? Like some things are sensitive that you have, some things aren't, some things are already secure, some things aren't. Like some news articles or research is misleading, there's conflicting information out there, and then there's all of these things that you just simply don't know. So like the first sort of practice that you have to do is kind of think about how can you start to, narrow down all of the stuff that is available out there. And one of the things that I learned when we were working on our threat detection report this year, or I guess I always suspected it, but I kind of validated it with data, is like thinking about what actually differentiates a company, right? So the threat modeling is based on this assessment that your company is unique, it has unique things about it, and a lot of people start off by thinking about the easy things, like the things that are going to make me different to an adversary are my industry or the size of my company. But I've found that those things actually don't really make that much of a difference. And the things that do, and these things are affected by industry sometimes, but it's sort of like secondarily. But the things that differentiate you are the technologies you use and the way you store and use data. So like we noticed worms tend to target manufacturers. It's not because worms like manufacturers, it's because manufacturers have more permissive USB policies because they're using legacy devices and things are air-gapped and they have a legit business case to let people plug a USB memory stick into a computer. Whereas a lot of enterprises just simply do not allow you to do that anymore because of worms have been such a problem for so long. The even more obvious one was like, oh, look, tech firms are facing more Mac OS threats. And it's like, no duh, because tech firms use Mac more than other enterprises in general. And I think of this, just to recap, as what I call the fighter jet shoemaker dilemma. So if you make fighter jets, you need to be really worried about advanced persistent threats. If you make shoes, your threat model is like, you need to be worried about like getting arthritis, right? So there's this, like everyone kind of exists in this spectrum between these two places, right? If you have no technology, you've got no cyber threat model, but everyone pretty much has some level of technology. And the reason that the industry stuff doesn't matter so much is because most threats are opportunistic, right? If like they're going to compromise you in whatever way they can. Things like crypto miners and ransomware, like they're not discerning about who they go after for the most part. If you have vulnerabilities like that are hanging out on the internet, easily available, they're probably going to get exploited. And then on the other side of that spectrum, like all of this APT stuff is extremely targeted and hard to plan for and unpredictable. And yet it's the thing that, if you read through all of these reports, gets talked about very, very often, particularly in the news, which is one of the reasons why like trying to track all this stuff can lead you down like sort of confusing and time-wasting roads. But so generally speaking, the factors that make companies similar are kind of more important in terms of threat modeling than the things that make them different, which is why I always harp on the importance of prioritizing prevalence when you're thinking about how you should like prioritize defensive controls, or in this context, testing, your testing priorities. And the other reason why this is kind of tangentially good is because asset management is really, really hard. And so if you don't have a 100% clear picture of everything that you have in your environment, then like just thinking about prevalent things, you're not gonna go wrong there, right? Like you're gonna have a better chance of casting a wider web against all the things that are likely to attack you if you focus on common threats and common attack techniques. And now we're getting to the meat of this. How do we figure out what prevalent is? Well, we said it before. You just read all the reports. Write down the things that occur across them, right? So here's the threat detection report. Here's the top threats that Red Canary saw this year. Here's the top techniques. Okay, cool. That's one input to figure out what it is. Here's the CrowdStrike report. That's another one. If you have a really good idea of all of the systems you have across your environment, then this is easy, right? You can just go through and be like, oh, these things aren't relevant to me because we don't use these. Those things are, and it narrows that list down. But again, like, it's still, even if you're able to narrow it down greatly, it can still be very overwhelming. So this brings us back to what we were talking about before, because what's really good at sifting through massive amounts of data quickly and finding commonalities? AI tools, large language models, machine learning, right? So they're really good at taking in a lot of content, text, finding those similarities, and then providing synthesis of that information to sort of like help you figure out what are the things that are actually common across all of these reports. And this is precisely what we set out to do this year, is like figure out a way we can leverage AI to make sense of all of this crazy disparate information that's being thrown at us on the internet every single day.
And it's not lost on us, right? Everything is being hit by the AI hammer, because clearly every problem has an AI nailed, right? And this is what you've all seen, is you either saw talks or went to the expo floor. It's like AI across all the things. But there are some really fundamental things that AI does really well, particularly generative AI and those kind of LLMs. And so, again, this mass amount of content, it's really overwhelming. And the expectation that any analyst or anybody in this room can comb through all the relevant threat reports being published by all the vendors all the time, and then being able to synthesize that, it's just crazy. Now, I mentioned before that we have a few prefaces to make here. So first and foremost, we are not AI, LLM experts here. That is not, we're just some security folks, and we work with practitioners all the time, and we are trying to use AI as a means to the end. So if anybody wants to learn how to make a model for themselves or something, sorry, that's not what this conversation's about. And also, we have to eat a little crow here about last year's talk. We made fun of AI quite a bit, I think, in that presentation, because it was such a buzzword last year as well. And we had this whole thing where we talked about Westworld for like 20 minutes. It was a thing. This is our kind of apology to everyone, because actually it turns out AI is really good at some stuff that we want to do.
I was very dubious last year when it was like very academic, and then between then and now, everyone built all these whiz-bang neat AI tools, and I was like, oh man, they're kind of cool.
They are pretty cool. And we're going to show you how cool they are. And our assumption about this audience in particular is that you're all InfoSec focused, but you aren't necessarily people who maybe use things like generative AI every day. And you've heard of ChatGPT and all these other things, but like maybe you haven't sat down and stood up an account or tried to use it before. So the perspective for us on this conversation is you all are in InfoSec in some way or another, and you want to make your lives easier. And we're going to talk about how you can do that and kickstart your threat intel. and the synthesis and all the kind of defender things you may want to do, or offensive things. So why is AI so magic for this problem that we were trying to solve? And I know it's kind of, everybody uses magic in the term of AI, but for us, like, well, why is it? One, accessibility. Every single person in this room can use AI. There's so many options now. There's so many vendors and tools and commercial. It's all over the place. And a lot of it's free. Like, that's key. It's not us talking about some horrifyingly expensive tool that you need to go out to some vendor and buy from. Like, anybody in this room could do this right now. And that's a big key. And it's so powerful. Even these free tools that you get for just you set up on your phone. It's amazing how powerful these things are. And they're so flexible and so customizable by design that you can tailor it to your use case in ways that may be unexpected. And unlike a lot of technologies that are emerging and moving really quickly, what we're finding is things like generative AI is just trivial to learn to use. And we can attribute that in a lot of ways to, oh, here's a chat box. I know how to use a chat box, right? That kind of user interface, it's just easy. And you don't have to set up Docker images or all sorts of wacky stuff. Like, it just turnkey. And then the last thing here is a lot of security vendors are now just providing this, and it's baked in. You see here, Charlotte AI from CrowdStrike. You just have generative AI baked into the tools that your organization might already have. And so that kind of thing becoming more and more available to everyone is really powerful for our purposes. And this is really important. You get from AI what you put into it. And we mean that in multiple senses. So we mean it literally. AI isn't magic, even though they hallucinate sometimes, which we're not going to get into, but they can't generally create net new stuff. There's no net new knowledge that's being spat out by these AI things. And you really need to feed it a lot of data, what we're going to call knowledge for the rest of this talk. And there are some what are called retrieval augmented generation, or like RAG capabilities in these things, where they can crawl out and maybe grab a file off the internet, or you can give it a specific kind of file that it needs to be pulling from on a regular basis, or a service it needs to use, and that can pull in more of that data and information to help its literal knowledge grow. And that could be all sorts of things: data and files and resources and APIs and yeah. But you not only get from AI what you put into it from a literal knowledge sense, like literal data and words, but you also get that from a figurative sense. So the questions you ask it, the prompts you provide it, these things are incredibly important. Not just that you're doing it, because obviously it takes two to tango for some of this stuff, but how you phrase your inputs is staggeringly important. And we're going to give you some examples of that here in a bit. But there's wacky, crazy stuff that nobody fully understands yet. For example, they have found that you get better answers from a generative AI if you are polite in your prompts. Why? Who knows? I'm sure some scientists, probably someone in this room could explain that to us. I don't understand. Like, why is it that if you put please at the beginning of your prompt, it will give you a better answer than if you did not? I don't think we fully understand the scope of that. And that is one of those weird kind of quick tips that you can hear from us, and you're like, oh, I wouldn't have ever thought to do that, or why that would be beneficial. But it is, and we know this because we've been trying to wrestle this thing to the ground for a while.
But at the same time, and completely counterintuitively, and we'll kind of get into it in a minute, like, it also performs better if you're forceful, right? So it's like, there's all these weird things going on in here that we don't fully understand. And the rabbit hole on researching this is incredibly deep.
Yes. And it's one of those things that if you try to just do even an entry-level research into, well, why does it behave this way? You fall down this scientist rabbit hole, and I'm not an AI scientist, so it's tricky. Anyway, so let's ground ourselves for a moment. What was the goal? What were we trying to set out to do? Use existing threat intel reporting to provide end users with actionable priority lists of threats and threat actors based on the end user's technology stack. And we want to use this to improve our testing. And in many ways, Brian and I, as people in the information security industry, we've been for years trying to figure out this like one MITRE ATT&CK heat map to rule them all, obligatory MITRE ATT&CK reference. And that has been kind of like, well, what's a good centering point? How can people interact with their threat model in a really meaningful way? For years, this has been something we've been chasing, and it's not really been attainable because of the complexity behind this information. guess what, everybody? We think we might be onto something to solve for that problem. So how did we do the things that we're about to talk about? It was ridiculously simple to get started. In our case, we just signed up for ChatGPT Pro and created this thing called a custom GPT. And that gave us 3 things to focus on in the creation of that. For those of you, again, assuming that nobody in this room has done this before, there's 3 things you focus on. 1, capital K, knowledge. This is the literal data or files that you can shove into the GPT that it will use as part of that data in to help it grow and understand what it is you're looking for. And there's a 20 file maximum on that, just so everybody's aware for now. The next thing that we focus on is the instructions, and this is where we're going to spend a lot of time. Those are the way you phrase something and the kinds of things. Dear AI, I want you to do this under all circumstances. These are your rules. That's your instructions, and we're going to talk about that a lot. And then the last one was the way a user, the end person interacting with this thing, should communicate with it, and that's that whole use please sometimes. But what was funny was after we got started, signing up and getting our own custom GPT working was trivial. Finding all the threat reports we wanted to use was non-trivial. And it was so non-trivial that we were like, oh, are we going to have to click into a million weird ad boxes across every vendor site? It was nuts. Until we stumbled across Jacob Wilson's GitHub.
I don't know who you are, Jacob Wilson, but like, guys, go check this out. It's so thorough that when we tried to feed it to the GPT, it was like too much.
Yeah.
No.
Oh, also, do not try to just like git clone this repository. It is outrageously large because it's like hundreds of PDFs over multiple Git revisions. It's complete bedlam. However, Jacob Wilson, wherever you are, thank you so much for doing this so we didn't have to. But back to the point earlier about like threat intel reports. These are too much for a human to consume in their lifetime. We found that from a data perspective. Like we were trying to put a bunch of stuff into our GPT and say, like, hey, we want you to know about all these reports, and it's just like, nah.
Turns out it
too
won't.
much.
Not for $20 a month. It won't do it.
Yeah, and so I mean, it was too much for our AI as well, it felt really, really important. And we also stumbled across like you can only interact with these things for so much before it says, that's enough for one day. For $20 a month, you don't get any more talking to me. So there are some limitations around the way we set it up. Oh yeah, and these are the reports that we ended up using for our initial go, and I'll let Brian speak to that.
Yeah, so again, we had that 20 report cap. So I went through Jacob's list, and I was just like, what of these reports are the ones that I'm most familiar with, that I think are the best? And this is the short list I came up with. So we had the Red Canary Threat Detection Report, which selfishly I'm one of the main authors of, so I of course included that. Splunk, we added that because they've got a really, really good detection engineering focused research team, and their annual report's really good. Mandiant, world-class incident response, which is nice because it gives you a subtly different perspective than if you're looking at people who are doing detection, where you would kind of expect them to be seeing things earlier in the intrusion cycle. Mandiant seeing it much later because they're coming in to do incident response engagements. Obviously, Microsoft, literally, 90% of everyone's work computers are Microsoft, so they have more visibility than basically anybody. Palo Alto Networks, again, another huge InfoSec company that has a really, really good research and intel team. Same is true for CrowdStrike. Expel is nice because they do, they incorporate lots of different tools into their service. They have lots of customers. They're fairly large, and they have a really good annual report. The DBIR is obviously the industry standard. It has been for like 15 years. Wiz gave us really, really nice cloud visibility across these reports. And then obviously we included Cisco Talos, just because they're probably one of the preeminent publishing intel teams in our industry.
So once we gathered up which reports we wanted to use and feed to our AI, felt like we had a pretty good baseline based on our understanding as humans, like this is the kind of mix of information and actionable intelligence mixed with industry insights that we think would be really helpful for our purposes. Now, to make the magic happen, and again, the assumption here is you all are InfoSec people, not necessarily generative AI people. There's this concept of prompt engineering, and the most crayon version of this that I can explain it as is, this is iterative improvement of your text-based inputs, kind of the words or language you feed to this thing in order to get a response. Now, one really good illustrative example of that is the way that if you use ChatGPT's DALL-E plugin, which DALL-E is an image generation thing inside of ChatGPT. It's again, we don't need to go into the specifics of how all the AI things work, but it's kind of neat. So I fed ChatGPT plus DALL-E a single sentence. Please create a sci-fi representation of the term the art of the possible, right? Thematically appropriate for RSA. But ChatGPT does something for you after you put in that sentence and hit go. It expands that and does its own kind of prompt engineering. And this huge wall of text here is what it actually fed to the image generator. I gave it a sentence, and it expanded on that in order to give me a result that it thinks that I wanted, right? It expanded that out. This whole crazy thing of illustrate a futuristic cityscape where technology and human nature and harmoniously coexist, demonstrating the concept of the art. Like, it goes on and on and on. I didn't tell it to do any of this stuff, right? But this is a really good example of prompt engineering, because had I written something like that in the first place, it probably would have given me something really neat, and it would have expanded further. So you can get some of this prompt engineering stuff for free because they are trying to help make your prompts better. But if you as a human are doing that and feeding it better and better inputs, better and better stuff is going to happen. Now, we did talk to some really smart AI people in working on this presentation. And there was one lesson we learned out of the gate that was really, really compelling. And it was told to us that we should think of AI as a child. And this idea of simple versus complex instructions, right? This idea of go make a sandwich versus put a slice of bread down, then put jam on one side, then put the other slice of bread down, put peanut butter on that side. This idea of thinking of an AI as a child who doesn't really fully understand what you want at first glance is important. And there's some really bonkers eccentricities that we stumbled across. For example, we were making lists of things that we were telling the AI to do. And we were using dash, and then we'd write the words, and dash, like write the words to make the list. It would just forget stuff in that list. Just like, nah, everything after the second bullet, sorry, I don't know anything about that. And then we just swapped it out, and we said 1 dot, the same words, 2 dot, the same words. And it's like, oh, cool, I got the whole list this time. Why? I have no idea. But those sorts of weird eccentricities and landmines are things we tripped over, so now you don't have to. Also, we learned that giving it sentences isn't great. It just kind of like drifts off every once in a while. But if you give it a list, it's like, oh, okay, that's fantastic. Ironically, I ended up using dashes in the PowerPoint, which is counterintuitive to the first bullet point we just made, but oops, whatever. And then we tripped over this really strange thing about forceful language. If you use strong language like should and always in your prompts, it will give you better results. Because however it's perceiving these sorts of things in the brains and jars that run in whatever data centers all this stuff happens in, that strong, direct language has a meaningful impact on the results you get out of the back of these things. And you wouldn't just assume that out of the gate, right? This is something you can learn from our mistakes. And these simple tweaks, they just had a massive impact on our results. So when we were creating instructions for this AI that we were working on, we were using just experimenting, and it was highly iterative. We would just sit down and work together and make change after change after change after change to try to get it to do exactly what we were expecting. And it was always, every time it produces a result, it's slightly different. And so that iterative that process was tricky. And this is where we tripped over another kind of counterintuitive thing. We were trying to define the goals of this thing's output. We knew the kind of results we were expecting to see. But we can only know those kinds of results because we are, I'll use lowercase e, experts in this field, right? And so those kind of goals are creating a meta example about what we expect as practitioners who should be there. It required that level of expertise. We had to have a crystalline understanding of our goals so that it would meet them, and how to use the language that it was expecting for us to produce that. And again, we tripped over all sorts of wacky eccentricities while we were working with it. Some other tips, if you all are going to do this yourselves. Old school, super simple debugging techniques work great. So for example, we would put in our instructions, in our rules for the generative AI, always begin your response with the word ahoy, right, as an example. And then we'd say, okay, every time you do this, make a list, and then end that list with 2 carets that says, that's everything I know. And then end all your responses with something like, that's all, folks, and then a version number that we would make up. Now, this seems really trivial. Anybody who's ever done any programming, it's like, oh yeah, console outputs. You do that throughout your program to make sure you hit them all. You can do that with AI prompting, and you may not have thought of that. But what's really cool is we could tell how much it was understanding our instructions by it would just drop off certain parts of our little debugging code here. It would not start with ahoy, or it would not do that that's all I know thing, or it would stop printing out the version number we were telling it to end every sentence with. And that was telling us that it was getting lost somewhere in our instructions. So these kind of old school debugging techniques, they just work great as you're trying this for yourself. So we got the thing up and running. We are kind of learning how to make it do what we want. And then we needed to create a baseline. What is the kind of correct example, request, response that we should expect from this? So we took an example organization that we knew, and we applied AI to it, and then we said, okay, let's check our results. Now here's an example of our first baseline prompt. And this is our don't do this. This is what we started with. I am a 500-person employee technology startup. Our employees use macOS. We primarily use AWS, da, 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 da. When we were feeding it this as an initial prompt, as our baseline, it would just forget of half the things in the sentence. It would just be like, nope, everything after that, I got bored or something, and it would just not know. And which was really strange. Again, we had to wrestle with it for a little bit to be like, well, why is it never bringing up the fact that we use GitHub in our response? And I can't explain to you why it would forget things midway through the sentence. All we know is when we turned it into a list, it did great. It always remembered it every time.
We also switched out macOS for Windows because we were like, I'm not sure how much information there is about macOS across all of this library of reports. So it was good to start like. So the structure of it was important, but the contents of it were important too. Like if you have really obscure stuff, your results are going to probably vary because there's going to be less information available across whatever your knowledge base is about those technologies. So we kind of took a step back and we're like, let's not overcomplicate this.
Yeah, if one of your line items in your tech stack is Novell GroupWise, it's just going to say, I'm sorry. I'm so sorry. You should just stop. Go home. But yeah, that's exactly right. As we were creating these baseline models, we were like, well, what's something more applicable for everybody? And this was a much better way for it to be itemized, and you can go ahead and have it understand more of the items in your list, which was really important. And so our initial results, we did all this stuff, and we created a baseline. It was all amazing, and then we hit go, and it didn't turn out very well when we first started. It would just forget stuff, and it would ignore things, and it was missing certain details. But the biggest problem we had was it just wouldn't use the knowledge we had fed it. It wouldn't use all those reports we'd shoved into the thing. And in particular, when we were first creating this, it wouldn't do it on the first time you talk to it. So you'd come up to the AI and be like, hey, I have 500 people and they all use Windows and all these things. And it would be like, cool, here's some stuff. And you're like, well, that's not specific at all. You didn't, and then you'd say, please use your knowledge and try again. And it would be like, oh, I got you. And then you'd see this little loading wheel that'd be like, I'm searching my knowledge. Hold on a second.
Yeah, when we'd see the purple thing pop up, it'd be like immediate dopamine hit.
Yeah,
it's working.
It's like, yes, it's working. But for some reason, it just wouldn't do that on the first go. And we had to try a ton of iterations to force this thing to no, use your knowledge every time you generate a response. And it was tricky. We did over 25 some odd iterations of these instructions to get them. I think it was over 35 at the end of the day.
Yeah.
And we posted them all. We're going to give a link to them all here in a bit so you could see how we fumbled around in the dark trying to get this thing to do what we want. So our initial results, not great. But as we started playing tennis with this thing, we started to figure things out. And you can see off of what we were just talking about earlier, how we got better. But again, even as we got better at getting the AI to do what we wanted, we had to use our expertise to say, oh, you know what, that result was way too general, or that was way too specific, or you should have cited your sources here, little AI thing, or like, is this really actionable insights? We want it to be actionable. And so we just used our human expertise to try to craft those instructions to a more meaningful way. And so being able to, if you're trying to do what we did and you know nothing about the information security industry, you might struggle to create those initial instructions. But ultimately, where we kind of landed was this formula over here, where our instructions that are like the system prompt, is another way to call it, is thing number one, use a your goal, colon, and then a sentence. Dear custom GPT, this is your goal. Then we gave it a numbered list of these are your rules. That's where we put our debugging stuff, and we would use language like, always do this, or if an input has that, then do this. But if it doesn't have that, then do this. And those were our debugging statements were. And then at the very end, we would add a definitions that says, hey, when we say threat priority list, this is what we expect to see out of that. And this was kind of the magic where we made a major breakthrough. And we were cooking once that happened. It was really impressive. And you can see one of our initial outputs here, and I can read it probably easier over here. But we said, give us a priority list. Here are your priority threats and techniques, and ransomware, that's your number one. Here's our analysis and mitigation and detection. And it was really, really impressive, the kinds of things that it would prioritize based on our analysis. And it really proved that what we were trying to do, which is like, we just told this thing a little bit about our tech stack, and it spat out a very legitimate prioritization list based on all this industry information. And frankly, it was really cool that it was just able to do this out of the gate. And once we got it to create that threat priority list that we've been spending hours upon hours working on it and crafting to do, then things got really suspiciously easy. And we're talking like trivial. So for example, after we got the result I just showed you, where we were like pretty happy with the threat, we said, okay, one of the things it brought up was process injection. That's something that affects your kind of organization and the technology you have. And we literally just typed in a sentence, create a defense validation test, or did I jump ahead? Yeah, no, here we go. Create a defense validation test for process injection that I can run locally on my workstation. So we just type that in, hit enter, and it spat out this. And it's like, oh, I can help you with that. Here's your preparation, here's the exact command you're gonna run, and this is how it's going to work. It was staggering. We didn't tell it anything about creating tests, nothing. Like we didn't add that to a system prompt, we didn't tell it, it just knew. And it knew that based off the kind of information we had fed it, off all the threat intel and actionable reporting that we had found. And we'd also fed it Atomic Red Team and a few other things, but it was incredible. Without any sort of instruction, we didn't tell it that it needed to give us a preparation step or an explainer or how to format its code example. It just did it out of the gate. It was amazing. And we were really fortunate that it understood that immediately. So then we took it a step further. It gave us an example test of something we could copy and paste into a Windows command line. Well, would it give us a detection analytic command? And then we said, please help me create a detection analytic for process injection. Bang. It spat out what we looked at as ostensibly correct SQL here, and it gave us a whole description on the front and back side of that about how it would work and how you would execute it and what you would expect to see. We didn't tell it to do that. It had no idea that that's what we were looking for, and it just did it out of the gate after we'd spent all this time getting it to be really, really good at understanding threat prioritization. And that's staggering that it could just do this out of the gate. And I want to emphasize that point. Like, we had no expectations. We thought we were going to have to do the whole thing again and teach it how to create these kinds of quick and easy atomic tests. And here's your detection analytic. It just knew how out of the gate. So when we wrote this slide, we were feeling real good. Everything was working. It was fantastic. And we said, there's not really a whole lot of shortcomings. Everything was pretty amazing after we got it dialed in. It learned from our reports, and even though we kind of had a subjective-ish what are top priority threats based on all this knowledge, it did a good job of creating that. It gave us objective-ish tests and detection analytics. That was really neat. And do we know for sure that all the commands it gave us were going to work in our environment? Well, no. You'd have to test that. But it was still a great way to kickstart what you were working on. Now, that's what this slide says. So we high-fived and submitted everything, and we're feeling real good. And then about a week went by where we didn't touch our custom GPT at all. And we came back to it, and we asked it the same baseline prompt. And things started to go sideways on us. It had forgotten everything we had talked to it about over all this time, and our instructions were just out the window, and it didn't work, and it wouldn't use its knowledge, and all these things started going wrong.
They're still sitting there. We're looking at the instructions in the GPT console. They're all there. All its knowledge is still uploaded there, but for some reason, it's just not looking at any of it or assessing any of it anymore.
And so we started to do some research, like what could be going on here? And this is one of the big caveats that we want to express to everybody. Keep in mind that in our case, like, we don't control this model. We, are paying ChatGPT to do this sort of thing for us. So they're making changes in the background. And as they push new versions and dump memory of this thing or whatever, like, it's out of our control. And so whatever was happening in the background at OpenAI, it broke some of what we were doing. And then we kind of were struggling with it, and we did a bunch of iterations, and then we left it for a week because we were frustrated, and we came back again. And it's like, no, I'm working now. Everything's fine. It's totally baffling for us. And that's a really important takeaway because, again, one of the limitations of us using free or inexpensive tooling is we don't control any of the background.
Reassuringly for ourselves, at least, like, we are not the only people who have noticed this. Like, there are deep forums of people complaining about basically the same problem.
Yeah, we looked up refuses to search its knowledge and found a mountain of people who were like, we're experiencing the same thing. So for a bit, we've just felt like, oh, it must be our bad. But no, there was something systematically happening in this proprietary engine that was different and out of our control. So that leads us to some of the places where this could all be improved. If you all want to do this for yourself, for example, like, there's all sorts of formatting consistencies in the threat priority that we used and what the bold and whatever. But the big one here is we think that if you gave what we've done to real AI experts, if any of you have people inside your organization, or if you yourself can stand up a proprietary model in a data center you control, and you could feed it these kind of instructions and system prompts, and productionizing it within your own organization and something that you own and control end to end, that's going to save you so much headache and heartache as you try to make these things work for you. And again, we have a general framework here that you could use all sorts of non-public reports in your knowledge, right? We just used a bunch of public ones, but you don't have to if you wanted to recreate what we've done. And you could add all sorts of stuff to that knowledge base. And another recommendation we'd have is if you have a canonical example of what you want in your threat priority list, all this generative AI stuff loves those kinds of examples, and you can be really discreet about that. And in the future, if you wanted to be more discreet about atomic red team tests, or you want to integrate things like Sigma or Stratus Red Team, it would be trivial to do that.
Also, this just occurred to me now, but pair an editor with whoever's doing the prompting for the AI model that you're using, because you want to have really sharp, concise language. So if you can have a data scientist along with someone to sort of help edit if they're not the strongest writer, it's going to be super helpful.
Absolutely. And so there's all sorts of configuration options you have. We've tried to make the framework of what we generated and the instructions we created to be pretty flexible. You could use all the vendor reports from a given year and private threat intel or whatever you'd like to have. And we were very general. We wanted to provide something that was convenient as a great learning example for people like you all who are thinking about doing this. And again, it was that convenience and little to no AI expertise was required to get started. But you may have a totally different intent with the kinds of synthesis you want to do for your threat intelligence programs or analyst programs or learning, and you can be as specific or granular or general as you want there. So this is our apply slide. Everybody has an apply slide here, and this is ours. So you can use, any of you can use our, we call it the InfoSec Community Encyclopedia, just because we needed a name, and it turned into a good acronym. And so we've got some links there, and then if you want to see what we did and the kind of instructions and iterations we went through to try to rack our brains against this stuff, we also have a link to that GitHub. And so we recommend that in the next week, you should identify some folks and team members who would benefit from maybe using our version of this. If you're struggling with consuming all this kind of threat intelligence information or reports and creating a threat model for your organization or prioritizing what kind of threats that you should prioritize, give it a shot. And use this to check your assumptions about what you thought your threat model might be. Because again, it's a pretty handy tool, even though we have kind of mixed results with it on a given day every once in a while. Then after that, in the next 3 months or so, we'd recommend you all collect the threat intelligence you find useful and prepare to use that in a way that works for you. So whether it's a custom GPT or make your own thing and use your own data scientists, that's a really good way to move forward from there. And we highly recommend in the next 6 months, pretty much everybody should be using something like generative AI to level up your staff. There's way too much information out there for any person to consume. The expectations that we'd set ourselves for the industry were unrealistic, and thinking that we could ingest all this stuff, especially human word versions of these things, not just JSON files you get from a vendor. There's a lot of it, and you have someone, or something that can help you parse this stuff in the form of generative AI. And definitely, if you have senior staff who use this stuff every day, ask them for help and give them really explicit goals that you have. Say, we want to use generative AI to help our team understand this in a really meaningful way. And obviously, everybody can benefit from this, but particularly new and junior staff who are trying to learn about these reports and get started. It's a good jumping off point. And with that, I think we're done. So thanks, everybody, for coming out. I really appreciate it.
Yeah, and if anybody has any questions, you can come up to these microphones.
We've got
and
microphones
ask.
here.
If you don't want to ask in front of the crowd, we'll hang out for a few minutes.
If you don't want to do it in front of the microphone,
personally.
Yeah, we'll be around for a bit. So,
what's up?
This was the first one, I think, that I saw that really sort of tracked the effort of the practitioner to implement something. Lots of descriptions of the visions of how things can be applied that are very tangible and exciting, but really appreciated just everything that was covered here. My question is, in addition, when you create a custom GPT and you feed it, your repo of reports, is there any potential to also feed it something like the full Atomic Red Team database or the Sigma rules database or the MITRE ATT&CK framework?
Yeah, we did
Sigma,
that.
Yeah, there's Sigma. I think we crammed Sigma into it as well. Yes.
We tried to cram Sigma into it. So because of a file limitation, you have to get it all into one file. But what we did, Atomic Red Team in particular, every night it gets parsed into a single markdown file, and we just fed it that. And it's like, oh, this is great. And it was awesome. That's what drives its ability to produce tests exactly like we wanted. And it also knows about all of our tests. So it would do something like, oh, based on your threat model, you have this sort of, cloud injection or something like that. And be like, well, here's the threat report you should look at, and here's the citation. And also, here's the MITRE ATT&CK ID, and also, here's the Atomic Red Team test, and here's a link to it. Have a nice day. And it would just high-five you, and you'd be on your way. It was awesome that it does that.
That's awesome. Thanks.
Thank you. Yeah.
Cool. Yeah, I don't have a question, but I just wanted to reiterate what the other gentleman said. This is, I have to say, this is one of the best talks I've been to in the last 3 days. Very practical, very useful. Thank you.
Thank you.
Thank you.
We really appreciate that kind of feedback. Nobody came up to the mic and said they didn't like it, so that's a good sign.
They're going
All right.
to leave that in their private when they fill out the questionnaire.
Cool.
Well,
Thank you, everyone. Oh, yeah, you have one more. Yeah.
Yeah, Adam, I noticed that you're from CrowdStrike.
Yeah.
Right? I'm a CrowdStrike customer. So how are you guys actually using AI to train your CrowdStrike product to do better?
Oh, so. Yeah, we can't. I will say this. This is meant to be a completely vendor agnostic talk, and we're going to leave it with that. And now I can talk to you off mic. Perfect. Yeah, and you had something.
Yeah, I just wanted to really quickly say I came to this because I was trying to figure out how to use AI over a bunch of threat intel reports. I was trying to parse through them all, and we're a, I guess, Microsoft Copilot trial customer, but not Copilot for security, all right? And I just couldn't make it work in it at all, right? I just couldn't figure out how to get all those PDFs into it. And then I saw you guys giving the little, hey, we did this thing. I'm like, oh my God, they did all the work for me. I can't wait to go. So I just wanted to thank you for that. And then I guess, I don't know if anybody else is again, vendor agnostic. But if you're using Copilot, I don't know if anybody figured out a way to make this work for it, but I'd love to talk to you afterwards if you did.
Awesome.
Thank you.
Thank you. Anything else? Anybody else? All right. Travel safe, everyone.
Yeah,
Thank you for
you
your
guys
time.
so much for coming.
Yep.